Hello and welcome back to another higher mathematics video on differentiation. In today's video we are going to be combining what we've learned from the last couple videos on curves and stationary points, and we are going to put this into practice to do some curve sketching. Now before we get into what we need before we start sketching a curve, I do want to quickly note that it's very important that you bring a ruler into your exam because questions will come up where you are asked to sketch a curve, and it's very important that you do use your ruler when doing this. So, in order to sketch a curve, we need a few things before we actually begin to sketch it. And the three things that we're going to be needing in this video are going to be the x-axis intercept, so also we call these the roots, so the x-axis intercepts, and there might be multiple, so we say intercepts, we call these the roots. Now we did talk about these at National 5, so a few things that we're going to be doing might be already familiar to you. So to do this we solve, that doesn't even say solve, we solve for when y is equal to 0. We'll get to that in a wee moment. The second thing we need to sketch a curve is we need the y-axis intercepts, if any. There might not be any. Usually there are though. And for this, we need to find y for when x is equal to 0. And the third thing we need to do when sketching a curve is we need to look at the stationary points, which we kind of did at National 5. We talked about turning points and things like that. But at higher, we also need to know the nature of the stationary points, which we did talk about in our last video on determining the nature of stationary points. So be sure to go and check up on our last few videos before we get on to how to sketch curves. So let's get into an example. We are asked to sketch the curve with the equation y equals 2x cubed minus 3x squared. Now straight off the bat, you would have absolutely no idea what this curve may look like or how we're going to sketch it. So we do have to go through these three steps before we actually do sketch it. So I've kept them up here just so we can remember exactly what in these kinds of questions we are going to be doing. So as we said, the first thing we need to do is work out the y-axis intercept. So let's say the first step is to find the y-axis intercept. Now as we said up here, the y-axis intercept, we want to find y for when x is equal to 0. Now you can do y or x in either way around. I'm just starting with the y-axis intercept. So we said that this is when x is equal to 0, because if we look at a curve that crosses through the y-axis, just do a quick sketch here. If we look at a curve that crosses through the y-axis, let's say it looks like this, we would say that it crosses the y-axis when the x value is equal to 0. As we can see, this is when x is 0. It crosses through the y-axis. It will always be when x is equal to 0. So we know that if we're finding the y-axis intercept, we're just substituting in the point where x is equal to 0. So we would say that the y-axis intercept is 2 times 0 cubed minus 3 times 0 squared. Now because our curve completely depends on x, we know that it's going to be 0. So we say that the y-axis intercept is the point 0, 0. So that's our first thing we're looking for. The second thing we're going to be looking for is the x-axis intercept. So let's do that. Now again, I said you could do this in any order. It doesn't really matter. So let's do that here. Now this is just the converse to over here. We want to find it when y is equal to 0, because if we look at again, I'll do another little sketch down here just to help explain it. So if we're looking at the x-axis intercept, in this case, let's say we have a curve that looks something like, I don't know, like this. The x-axis intercepts are going to be here or here. These are the roots. And as we can see, this is when y is going to be equal to 0, because we've got this point here, its y value is 0, and this point here, its y value is 0. So the x-axis intercepts are simply when y is equal to 0. So we just rearrange our equation to get 2x cubed minus 3x squared is equal to 0, and we just want to solve for x to find the x coordinates first. So to find the x coordinate, we can start by taking out a common factor of x squared, and we'll get 2x minus 3 equals 0, and from this we can see that x is going to be equal to 0, because we'll have x squared is equal to 0, or x is equal to 0, and we'll also have that 2x minus 3 is equal to 0, which gives us 2x is equal to 3, or x is equal to 3 over 2. So these are both our x coordinates for the x-axis intercept, and because we said the y coordinate is just going to be 0 at these, we would say that our x-axis intercepts are going to be 0, 0, and 3 over 2, 0. Okay, so I've just rewritten these up here to give us a bit more room to work with, because as you can see, for our final step, we have to work out the stationary points and their nature. And if you remember from the last video, it does involve quite a lot of working. So I've just cleared up some room to do this. So for the first step in working out the stationary points, we know that stationary points occur when the derivative is equal to 0. So we actually need to start by working out the derivative. So we do our differentiation rule. We're going to get 6x squared, and then 3 times 2 is minus 6x. And then we say that stationary points, which it's fine to abbreviate to SP, but stationary points occur when the derivative dy by dx is equal to 0. So therefore we have 6x squared minus 6x is equal to 0. We can take out a common factor of 6x. We'll get x minus 1 equal to 0. And like we did before, we just solve for x to see that x is going to be equal to, well, in this case, 6x equals 0, or x equals 0, and x minus 1 equals 0, so x equals 1. So these are our two x coordinates for the stationary points. So how do we work out the y coordinates now that we've got them? Well, we simply just substitute them back in to the equation of the curve. So when x is equal to 0, we say y is going to be, well, we can just see that y is going to be equal to 0. So that's the first one. And we have when x is equal to 1, this time we will actually substitute it in to get that y equals 2 times 1 cubed minus 3 times 1 squared, which is just 2 minus 3, which is going to be minus 1. So the coordinates of our stationary points are the x coordinate 0 and y coordinate 0, sorry. So that's our first stationary point. And if you remember, we said that is also the y-axis intercept and the x-axis intercept. So we know at the origin of our graph, we know that there's going to be some sort of stationary point that will exist there. And we also say our second one was when x is 1, y is minus 1. So 1 minus 1. So these are our two stationary points. The last thing to do when we've worked out the stationary points is determine their nature. So we do our nature table. So for our x coordinates, we have 0 and 1. So just label them down for us. And we want to work out dy by dx of each of these points, and then therefore what the graph is going to look like. So when we substitute in 0 into dy by dx, we get 6 times 0 squared, which is just 0, minus 6 times 0, which is, of course, 0. And when we substitute in 1 into this, we get 6 times 1 squared, which is 6, minus 6 times 1, which is 0. So that's what we're looking for. So we know that these are confirmed stationary points. Now we want to look at what the graph looks like as it approaches the value x equals 0, and as it leaves the point where x equals 0, and the same when x is equal to 1. So to do that, we look at points that are very, very close to 0, because if this stationary point, for example, was a maximum turning point where this is 0, if we look at right before 0, say minus 0.1, we will see just before the stationary point if the curve is increasing or decreasing. So again, that's what we're doing here. So we'll look at the point, say minus 0.1, and just after 0, let's say 0.1. Similarly for the point 1, we'll look just before it and just after it, and we want to substitute these values, these 4 values, into our derivative here, where x is going to be these values. And again, we don't care what the value is, we only care if it is positive or negative. And I'll just tell you now, when you substitute in minus 0.1, you do get a positive value, so we'll put a plus. And when you substitute in 0.1, you get a negative value. Then when you substitute in 0.9 into this here, you will get a negative value. And when you substitute in 1.1, you will get a positive value. So now we can sketch show what the graph's going to look like at each of these 2 stationary points. For this one here, we say that it's increasing here. 0 is going to be the stationary point, and then we say it's decreasing. And we can already see that that's going to be a maximum stationary point, because it's going to look something like that. And over here, we say it's decreasing, which is what the negative means. 0 means it's flat, and then positive means it's increasing. So this one's going to look like that, so we can tell it's going to be a minimum stationary point. So now that we've got these, we will simply say that 0, 0 is a maximum turning point. And we'll say that 1, negative 1 is a minimum turning point. So now we have all 3 things we need. We have the y-axis intercept, 0, 0, the x-axis intercepts, or the roots, we've got 0, 0 and 3/2, 0, and we also have both stationary points. So this is where we get on to sketching the curve. Okay, so we're going to sketch the curve now. Now it's important when you do this question to keep all your working. I've just rubbed mine out so we can have a big graph here and have more space to work with. But I've kept all the 3 important things that we need to work out. So we have the y-axis intercept, the 2 x-axis intercepts, and our 2 turning points, which are our stationary points. Now we just want to plot all these on the graph, on the graph, so we can see what it's going to look like. So we've got the y-axis intercept 0, 0. So we have a point which is going to be at the origin. I'm going to make them nice and big. And we also know that that's also the x-axis intercept. And we also have that 3/2, 0 is going to be an x-axis intercept. So we'll just pop that, say, somewhere over here. And it's important that we label this 3/2. And then we're going to label our turning points. So we know that 0, 0 is a maximum turning point. And we know that 1 minus 1 is a minimum turning point. So that's going to be about here. So we say that 1 minus 1 is our final point. Now, as we said here, as it approaches 0, we said it's a maximum turning point. So we know the graph is going to approach 0. It's going to turn at 0 and start to head down because that gives it a maximum. And we said that 1 minus 1 is a minimum turning point. So we can see as it approaches this point, it's going to be negative, and then it gets positive as it leaves it. And then we've said that 3/2 is the x-axis intercept, so we know it's going to go up to there, and then we can say that it just keeps going up at that point, like so. And this is us. We've now sketched the curve. We don't know what it looks like after this, or before or after this, so this is all we can sketch. And we would say that this is our curve with the equation y equals 2x cubed minus 3x squared.